Question 7. Ammonia reacts with aluminium chlorine as shown by the equation NH3 plus AlCl3, H3 and AlCl3. Draw diagrams to illustrate the shapes of NH3 molecules and of AlCl3 molecules. So we've got nitrogen, NH3, ammonia. So we're going to have a hydrogen, and a hydrogen. How many is it going to have any lone pairs? Well, nitrogen is in group 5. You can see 5 and nitrogen is the first one there. So it's attached to 3 elements, 3 hydrogens. So it's going to have 2 electrons. So we're going to have 1 lone pair of electrons. AlCl3, well, AlCl3. Aluminium is in group 3, attached to 3 chlorines. Chlorine. Therefore, it's not going to have any lone pairs of electrons because it's bonded to as much. That's the maximum number of bonds it can have. AlCl. And so no lone pairs of electrons. Now the bond angles. Well, for this one, NH3, because it's got a lone pair of electrons, it's going to be 107 degrees. 107 degrees. And for AlCl3, 120 degrees of bond angle. 7.2. Name the type of bond formed between N and Al and H3 and AlCl3. It's going to be dative coordinate. Dative coordinate bond. Usually 9 times out of 10, anytime it asks you to name the type of bond formed and it's about lone pairs and you can see that kind of topic, it's usually always dative coordinate bond. Why? Because both electrons, or the shared pair of electrons, both electrons came from the nitrogen in NH3. So came from the nitrogen from NH3. I just put NH3 in brackets. 7.3. Explain how the value of the Cl-AlCl bond angle AlCl3 changes, if at all, on the formation of the compound H3N-AlCl3. Well, the bond angle, think about aluminium now, it's now surrounded by 4 electron pairs. Aluminium is now surrounded Aluminium is now surrounded by 4 electron pairs, aka tetrahedral. And therefore the bond angle Cl-AlCl decreases from 120 degrees to 109.5 degrees. That is the end of question 7.